Have you ever wondered why the moon turns a haunting shade of red during a lunar eclipse? This celestial phenomenon is a spectacle to behold, a dance of our planet, the sun and the moon. Lunar eclipses, while not uncommon, are often shrouded in mystery and misconception. Some see a blood-red moon and think of prophecy, others of science. So what causes this eerie transformation? What's the truth behind this crimson spectacle? In the next few minutes, we will unravel the science behind this celestial spectacle. To understand lunar eclipses, we must first comprehend the celestial ballet of the Earth, Moon and Sun. Imagine the Sun, Earth and Moon as dancers on a cosmic stage. The Sun, our dazzling star, remains fixed at the center, casting its radiant glow upon the other two. The Earth, our home, is the first dancer, twirling around the Sun in a yearly rhythm we call an orbit. Now enter the Moon, our second dancer. It gracefully pirouettes around the Earth once every 27 days. This dance, dear listeners, is the Moon's orbit. The Moon's orbit isn't a perfect circle, but rather an ellipse, slightly stretched out like a squashed ball. In this grand ballet, there are moments when the three celestial bodies line up perfectly. This alignment is known as syzygy, a term borrowed from ancient Greek meaning yoked together. During a syzygy, the Earth is sandwiched between the Sun and the Moon. But what does this have to do with lunar eclipses, you might wonder? Well, it's all about shadows. When the sun is shining and you are standing outside, your body casts a shadow, right? The same principle applies to our Earth. When the Sun, Earth and Moon align, the Earth casts a shadow out into space. This shadow has two parts: the umbra, the darker central part where the sun's light is completely blocked, and the penumbra, the lighter, outer part where only some of the sun's light is blocked. Now picture the moon drifting into this shadow. If it passes through the umbra, the moon becomes dark, as if it's disappeared from the night sky. This, dear listeners, is a lunar eclipse. When everything aligns just right, we witness a lunar eclipse. As we delve further into this cosmic phenomenon, we shall unravel more of its mysteries and its captivating allure. But for now, let's marvel at this celestial ballet, where the Sun, Earth and Moon dance in perfect harmony. As the Moon slips into the Earth's shadow, the lunar eclipse unfolds. A celestial dance of shadows begins, a ballet of light and darkness that paints the night sky with breathtaking hues. To understand this spectacle, we first need to understand the Earth's two shadows, the penumbra and the umbra. Imagine the Earth as an opaque ball, and the Sun as a distant light source. The Earth casts two types of shadows: the outer, lighter shadow, known as the penumbra, and the darker inner shadow, called the umbra. When the Moon first starts to move into the Earth's shadow, it is entering the penumbra. This is the beginning of what we call the penumbral phase of the eclipse. However, the change is so subtle that it's almost imperceptible to the naked eye. It's as if the Moon is gently touched by a whisper of shadow, a soft hint of the drama to come. As the Moon continues its journey, it begins to cross into the umbra, the innermost and darkest part of Earth's shadow. This is when we start to notice a visible change. The Moon, in its celestial dance, starts to disappear, slowly consumed by the creeping darkness. This is the partial phase of the eclipse. A dark curve grows over the Moon's surface, a shadowy bite taken from the luminous celestial body we're so accustomed to seeing. Finally, the moment we've been waiting for arrives. The Moon, now fully bathed in the Earth's umbra, becomes a ghost of its former self. This is the onset of the total phase of the lunar eclipse. But the Moon doesn't simply vanish. Instead, it takes on a mesmerizing red glow, a phenomenon caused by the bending of sunlight around the Earth. But why does it turn red, you might ask? This is due to the Earth's atmosphere, which scatters shorter wavelengths of light, such as blue and green, while longer wavelengths like red pass through, bathing the Moon in a coppery glow. As the Moon fully enters the umbra, the total eclipse begins and the Moon takes on a red glow. A sight to behold, a testament to the grandeur of our universe, the lunar eclipse continues to mesmerize us, a celestial spectacle of shadow and light. But why does the Moon turn red, you ask? The answer lies in the atmosphere of our very own planet. To comprehend this celestial spectacle, we must delve into the realm of light and how it interacts with our atmosphere. You see, light is not just a singular entity, but a collection of waves, each with its unique length. The sunlight we observe is a medley of different wavelengths, each corresponding to a different color. This kaleidoscopic array of light, when it reaches the Earth, encounters our atmosphere. Now, our atmosphere is filled with tiny oxygen and nitrogen molecules. As the sunlight interacts with these molecules, a phenomenon known as Rayleigh scattering occurs. Named after the 19th century British physicist Lord Rayleigh, this principle explains why the sky is blue during the day and red during sunsets and sunrises. In Rayleigh scattering, shorter wavelengths of light like blue and violet are scattered in various directions more than the longer wavelengths such as red and orange. However, during the day, our eyes perceive the scattered blue light as the color of the sky, because our eyes are more sensitive to blue light and because sunlight carries more blue light to begin with. So what happens during a lunar eclipse? As the Earth casts its shadow on the moon, the sunlight passing through the Earth's atmosphere gets bent or refracted. This refracted sunlight then illuminates the moon. But remember our lesson on Rayleigh scattering? Yes, the shorter wavelengths scatter away, and only the longer wavelengths, the reds and oranges, manage to get through. This process paints the moon with a brush of crimson and orange hues, transforming it into the eerie yet fascinating spectacle we call the blood moon. It's like watching a sunrise or sunset happening on the moon, a cosmic show of lights and shadows playing out thousands of miles away. So the blood moon's crimson hue is a gift from our Earth's atmosphere. It's a reminder of the cosmic ballet that we are a part of, and a testament to the marvels of the universe that never cease to astound us. Lunar eclipses have fascinated humans for centuries, and they can be a thrilling event for stargazers today. From ancient civilizations to modern-day astronomers, lunar eclipses have always held a certain allure. In early history, they were seen as omens or divine messages, stirring fear and awe in equal measure. Civilizations like the Babylonians and the Mayans meticulously recorded these events, understanding their predictability and using them as tools for timekeeping and prophecy. In many cultures, lunar eclipses have been woven into folklore and mythology. In Vietnam, for instance, it was believed that a frog was swallowing the moon during an eclipse. While in Norse mythology, it was the sky wolves chasing and gobbling up the moon. Today, we understand the science behind these celestial events, yet they haven't lost their charm. Lunar eclipses offer us a chance to witness the grand dance of celestial bodies, a spectacle that serves as a humbling reminder of our small yet significant place in the cosmos. So, how can you best experience a lunar eclipse? Well, one of the great things about these events is that you don't need any special equipment to observe them. A clear, dark sky is your best friend here. Depending on your geographical location, you may need to stay up late or wake up at dawn. Check reliable astronomy websites or apps for exact dates and times. And when the time comes, find a comfortable spot away from city lights if possible. Watch as the Earth's shadow slowly creeps across the moon, turning it from its usual bright white to a deep blood red. It's a slow, gradual process, but one that's worth every minute of your attention. Remember to soak in the atmosphere too. Feel the chill of the night, listen to the hushed quiet, and let yourself be drawn into the cosmic ballet unfolding before your eyes. An eclipse is a reminder of our place in the cosmos, a spectacle that connects us with the universe. So, we've journeyed through the fascinating science of lunar eclipses. Together, we've untangled the enigma that has puzzled humanity for centuries, and we've done it using the power of understanding and knowledge. We started by deciphering the intricate dance of celestial bodies, learning about the precise alignment of the sun, the earth, and the moon. We discovered how this alignment, a cosmic ballet if you will, sets the stage for the phenomenon we call a lunar eclipse. We then delved into the heart of the eclipse itself, into the shadow. We explored how the Earth, acting like a colossal screen, casts its shadow on the moon, plunging it into darkness, but only for a brief spell. This is the umbra and penumbra, the two parts of Earth's shadow that play a pivotal role in the staging of a lunar eclipse. Our journey then took us to the spectacle of the blood moon. We learned how this ominous name isn't tied to any supernatural law, but instead it's the result of Earth's atmosphere bending sunlight, painting the moon a deep, striking red. And finally, we discussed how these lunar eclipses affect us and our planet, suggesting that we're all part of this grand cosmic ballet. Next time you gaze up at a blood moon, remember you're witnessing the grand dance of celestial bodies and the atmospheric magic of our own planet. Until next time, keep looking up.